Alright, so in this question here, it says that there's a certain car that's traveling 50 miles per hour due south. So the diagram here explains how this thing works. It's driving here due south, 50 miles per hour, and the police car is driving due west, 40 miles per hour. Now, apparently, this first car, the normal car, is basically half a mile north of the intersection. So this distance here is half a mile. And then the police car is 1/4 miles due to the intersection, so this is 1/4. If this is the rate of change, if this is what we call x and this is what we call y, so the rate of change of y, the speed of y is -50 because it's going downwards, and the speed of x, again x prime, the rate of change of x, is -40 because again it's going into this direction. So these are the first things I know. I also know that x value itself is equal to 1/4 miles, just like what's given here in the question, and that y itself is equal to half, just like what's given again in the question. What I'm asked to find out is the radar in this police car measures the rate at which the distance between the two cars is changing. So I need the change in distance between these two cars, right there. Let's call this d. Now this seems to be similar to a right triangle. If this is x, this is y, this is the 90 degrees, I need to find this one. Let's call this one d here. So what relates all of these together? I need the rate of change of d. So the d in this case is supposed to be equal, using the Pythagorean theorem, equals to the square root of x squared plus y squared. Now if I need to find the rate of change, I need to find d prime. But before I can find d prime, I first need to know how to derive this one the easiest way. I need to rewrite it as a power of half. So x power 2 plus y power 2 and all to the power of half. To start deriving this, I'll say half first, multiplied by whatever is inside the bracket as it is, all to the power of -half. Then I'm going to multiply by the derivative of what's inside. So in a big bracket here, I'll say the derivative of x squared, which will be 2x. And then we said earlier that x and y are functions of t. So I need to multiply by the derivative of x, which is x prime, plus 2y, and then multiply by the derivative of y, which is y prime. Now all what you need to do is to substitute the givens in this question and find d prime. So I leave this as d prime as it is, then it's equal to half. Now instead of the x, I'll substitute the value of x written there, which is 1/4. So I'll say here 1/4 all to the power of 2 plus the value of y, which is half, all to the power of 2 to the power of -half. Then this is multiplied by 2 and then x, which is 1/4, multiplied by x prime, the rate of change of x, which is again, we wrote over here at the very beginning as -40. Then we add 2 multiplied by y, which is 1/2, and the rate of change of y, and we wrote it there as -50. You just need to put this on your calculator and you'll get the answer as -62.6, of course, miles per hour. But then the speed can't be in a negative form, so basically the radar is just finding out the speed at 62.6 miles per hour. Just a note to take in mind after this is that this speed here is not accurate because both cars are moving, the radar itself and the car. So that's why in real life, most of the time the radars are in a stationary position. It's somewhere where it's not moving, calculating the speed of the other car. And that's it.